Hello, we're going to do 161 and 162, so let's do it. 161 states, doctors believed that a patient who received a pacemaker seemed to snore less. So this idea sounds like a direction. Okay, so it says, among the 40 randomly selected patients with a pacemaker, 12 snored. So I either have a pacemaker or I don't have a pacemaker. And I either snore or I do not snore. It appears as if among the 40 that have a pacemaker, so there's 40 here that have a pacemaker, it says 12 snored. And then it says 60 randomly selected without a pacemaker. 25 of those snored. Now, it looks like I could fill in my table here and I could do an association test, but this is saying that I might want to look into doing a confidence interval about the difference. So we're thinking about these are two populations of people. One population of people have pacemakers and one population do not. And it looks as if we're trying to find a difference. So instead of doing my H sub O, H sub A as there is an association, I'm going to do my H sub O is the proportion of people that snore. So I have a proportion of people that snore with a pacemaker, and I'm trying to figure out, we have a reason to believe that that might be less. So we believe, the doctor believes, H sub A, that the proportion of people that snore with a pacemaker, the portion of people that snore with a pacemaker, is something less than the proportion of people that snore without the pacemaker. And so there's a lot of words there, but you get the point. So the doctor believes or has a hunch that the proportion of people that snore with a pacemaker might be something less than the proportion of people that snore without a pacemaker. And so we have to start with the assumption that they might be the same and see if we can do a confidence interval to prove that there is a difference. Remembering as well, I could write these same things out and say that H sub O is, if I subtract them and I get 0, there is no difference. That's another way to write my H sub O, and another way to write my H sub A would be, I believe, if you subtract, would be this one. Okay. So now let's take a look at an actual question. It seems like I'm going to need my fancy calculator. So I go down here to my open screen, and I want to enter in these two proportions, and these are definitely yes or no questions. So I'm going to go here to statistics, and I'm going to do a confidence interval. And now I got to figure out which one is best. So I'm looking at this, and these are definitely yes or no answers, and we're actually doing two proportions because it looks as if I have two proportions here. The proportion of people that snored with a pacemaker and a proportion of people that snored without it. And so we're going to call success snoring, apparently. So success, 12 people snored out of 40, and 25 people snored out of 60. And we're going to do a confidence level of 95 because that's what it says in item 2. So I'm going to go down, hit OK, zoom in, and I'm looking for my C upper and my C lower. So it appears as if my C lower is negative 0.3 and upper is 0.07. And it looks as if that's exactly what 2 says. So I'm going to write true. Now we're looking for which one is not true. So since we know 2 is true, B is definitely out, and E is out. Okay, so let's keep going. And now it says, anytime you do a confidence interval for a difference between a proportion, you're definitely going to look for whether or not there's a 0 in the interval. Because if there is a 0 in the interval, right? If there is a 0 in the interval, that means that there isn't a difference. So it says, since the confidence interval contains 0, which in fact it does, there is a significant difference between the two proportions. No, there is not. Since we basically calculated that, yeah, there's a difference in these proportions, but not enough. And again, how am I saying there is a difference in the proportion? My calculator actually calculates that. So it basically is saying 30% of people that snore. So if you took this and did the math, 12 out of 40 would be 0.3. 30% of people snore with a pacemaker. And the other proportion says is close to 0.42. So 25 divided by 60 is 0.42. So you can see why the doctor has a hunch. It does seem as if he collected information, but since it appears that they are not, 0 is contained in this interval, then we don't have significant enough evidence to show that there is a difference between the pacemaker and not having a pacemaker. So now we know 3 is false. And we are supposed to be identifying false. So we've basically narrowed it down to C and D. Now let's figure out if 1 is false. The evidence supports the theory at a 10% level. So let's change the level of the test. Well, we could do that by doing if we change the level, that would be a 90% confidence interval, because a 95% confidence interval is at a 5% level. Okay. So we can do the exact same thing again. This will be good practice anyway. I'm going to do a confidence interval, still a 2 proportion, still 12 successes out of 40 people, and 25 out of 60 people. And I'm going to change this confidence level to 0.90 and see what kind of an interval I get. So when I focus in on my interval here, I get negative 0.27 and 0.04. So let's compare that here. At a 95% confidence interval, I got negative. All right. And my new numbers, I got still a negative. Uh-oh. So noticing here, I still have 0. So this would not be significant enough evidence to show that there is a difference between the proportion. So in fact, this has to be false, which is why I'm going to select D. Now let's go to the next question. It states, a coach did some collection of information and he calculated, or he collected observations of if a student was under 200. So it looks like he had 87 students under 200 that lifted under 200 pounds, and he had 63 students that lifted over 200 pounds. And he's trying to figure out if there is a relationship. So he also observed that of these students, 44 weighed under 150 and lifted under 200. So this is actually his observations. And then you can see he's just totaling up his observations. And as stated, it looks like he surveyed 150 students. So they're asking, based on the information, what would be correct? They're asking what if the chi-squared value is small or not. They're asking if there's a linear relationship between these, and that doesn't make sense. These are two categorical questions, not quantitative questions. They're asking about my p-value of the test, so let's figure out. These look like expected counts, so out of, if this data was purely random, you'd expect 40, and he got 44. You'd expect 47, and he got 43. And so these are actually the chi-squared values, and then it looks as if they already added these up for us. If they added up these chi-square values once they calculated the expected value, And those added up to 1.74. So if you add up all these numbers, you don't have to, but if you do, you get that value. And that does look like a relatively small value. They also got a degree of freedom of 1, which matches, remember we take n minus 1 here. So 2 minus 1 is 1. Then you take n minus 1 here. 2 minus 1 is also 1. And you take the row times the column. So 1 times 1 is still 1. So if I take my formula sheet and I look to see my chi-squared values, I end up getting a probability level of this. And now I'm not too excited about that because a p-value of 0.186, which indicates no significant relationship. Well, it looks like we have some relationship. We did not get exactly what we specified. So I don't like the fact that it says there's no significant relationship. Actually, I take that back. Since we got a p-value, sorry about that, that's greater than 0.05, we can say that there may be some relationship, but it's not significant. So I actually do like this wording. I've changed my mind. The p-value of the test is definitely this, which indicates there's no significant relationship between the two, and that's absolutely right. So definitely I like D. Why would I maybe not, well, that's not my p-value. My chi-square is so small. Okay, I agree my chi-square value is small. So let's think about this. On my chi-squared table, the chi-squared values get smaller as I go to the right. And the reason for that is that the bigger the chi-square value is, the more rare that outcome because it's because the expected value was further away from the observations. So it says since the chi-square value is so small, there's a strong relationship between them. No. That's the opposite. If the chi-square value was big, that would be proof that there's a strong relationship between the two. So we know this is not correct. Then it says, since the chi-squared value is so small, there is no evidence of a relationship. Yeah, and that's what I wanted to talk about. There is some evidence. It's just not significant enough evidence. There's not no evidence, where in fact this is some evidence. So we're going to rule out B. We already ruled out C and E, so we are positive our answer is D. Thanks for joining us.